So after you acquire a signal or before generating a signal, you might need to process it on the FPGA. So you might need to do some calculations, you might need to do some arithmetic, run it through algorithms, filters, or FFTs, and things like that. So this is all part of signal processing. So the signal processing that we're going to talk about right now is, as we see on this graphic, is going to be the signal processing that's happening on that FPGA VI. So now we're going to talk about using fixed point data types. What's so good about fixed point data types? Well, they provide some of the flexibility of floating point data type, but they also maintain the size and speed advantages of integer arithmetic. So what that means is it's going to allow us some flexibility to get something close to floating point calculations, but because of the size and speed advantages, it's going to take up a lot less space on your FPGA. So when you're using a fixed point data, you're going to need to configure the appropriate range when you're doing math and using the data types, and we'll talk about this more in later slides. Also, one thing to be aware of is the fixed point data type is going to be limited to a maximum size of 64 bits. Okay, let's talk about fixed point data types. So a fixed point is a collection of data types with different ranges of values. So these ranges are going to be defined by a minimum value, a maximum value, and a delta. Okay? And the way that those ranges are going to be determined are based on three different factors that we're going to talk about in the next slide. So one is sign encoding, another one is word length, and lastly there's integer word length. So these three values are going to determine what the range of that fixed point data type is going to be. So let's walk through these. So what is sign encoding? This is the option that determines whether the fixed point data is going to be signed or unsigned. So if it's signed, it can represent positive and negative numbers. If it's unsigned, it'll only represent positive numbers. Another one is word length. So this is going to be the total number of bits that are used for your fixed point data. So this is going to kind of determine the precision that you have with your fixed point data. And lastly, there's integer word length. This is going to be the number of bits used in the integer portion of your fixed point data. Okay, so this will make a little bit more sense on our next slide when we go into a demo. So for this demo, we're going to observe how sign encoding, word length, and integer word length affect the minimum, maximum, and delta of a fixed point data type. So if you want to follow along, you can go to your exercises folder and open up the demonstrations folder and go to the fixed point data type folder. So let's go into LabVIEW now. Okay, so let's go into LabVIEW and open up this demonstration. And let's go ahead and run this. Okay, so in this demonstration, I'm going to go through some of this VI and show you how to use it to try to understand fixed point data. If you want to understand it a little bit more, you can try to open it up yourself and play with it more after this demo. Okay, so let's talk about what fixed point data is. And what I'm going to try to get you to understand in this demonstration is how sign encoding, word length, and integer word length affect your fixed point data. Okay, so in this demonstration, we're going to use a sign encoding of unsigned, which is represented here by this plus sign. The word length here is going to be 8, so that means we're using 8 bits of precision to represent our data. Okay, so that's why we have 8 digits here. And then lastly, what we're going to play around with is what the integer word length is going to do for this configuration. Okay, so right now, again, we have 8 digits of precision here, and let's take a look at the integer word length. So what that's saying is there's going to be 8 digits here that are going to represent our integer length. So here we've got 1, 2, 3, 4, 5, 6, 7, 8, all representing integer data. Okay, so we've got 2 to the 0 here, 2 to the 1, 2 to the 2, and if you add this all up, it's going to be 255 is our maximum in this current configuration. If we want to look at our minimum, if we set these all to 0, notice our minimum is 0, and if we look at this this bit, we're going to get a delta of 1. Okay, so not too bad so far. Now let's see what happens if we shift this over the decimal point to here. Now notice that we have 4 digits here that are representing our decimal, and 4 digits here that are representing our integer. So notice over here, the integer word length now is 4. Okay, so if we take a look at this, what's the maximum that this can represent. So if we do 1, 1, 1, 1, we have 15 here, and then 1, 1, 1. This is going to represent the decimal portion, or the fractional portion. So if we take a look at this, our maximum that we can represent with this configuration is 15.9375. Okay? And the minimum delta that this can represent is 0.0625. Okay? So real quick, I'm just going to show you another thing here, and I can actually bring this out to here. Okay? So if you have an integer word length of 9, this is the configuration that you're going to get. So again, your minimum is going to be 0, but your delta now is going to be 2. And your maximum that you can represent with this configuration is 510. Okay? So let me close that down to zeros again, and let me show you the other direction. So if we go in the other direction, notice that your integer word length can actually be -1, and this is how that would be represented with the bits. So the minimum again is 0. Here, the minimum delta that you can achieve is this number right here, and the maximum that you can achieve with this particular configuration is 0.4980, and so on and so forth. Okay, so now you can see how the integer word length here can be negative, and it can also be something that is greater than your word length. So hopefully you've gotten a better understanding of how sign encoding, word length, and integer word length affect what your range of your fixed point configuration is going to be.